right. So the point being is that I still have to plug in my microphone back here, so I will do my best to enunciate and talk loudly. Well, as I was saying before I started recording, in this data collection unit, we've covered two of the three parts of it. The first part was simulations, where we learned how to simulate an experiment. We're kind of assigning digits to numbers, looking at probabilities, and going from there. The second half was survey, looking at observational studies, whether they be retrospective, whether they be prospective. We talked about the difference between those two last time. We talked about survey and bias, the biases that result, and then the survey, different types of ways to collect a survey or collect information. The last part of data collection, the last piece, is an experiment. Okay, an experiment is another method to collect data. And here are some vocabulary terms that you're going to need to know. Oftentimes, I will call the subjects of a study the experimental units, but they are in fact the ones that are receiving the treatment, and that's pretty important. Can I spell receiving right? It's I after E, except after C. I don't really know. Receiving the treatment. Is that right? Was this the class that I can't spell? Yeah. I remember that. Yeah. So experimental units, or the subjects of a particular experiment, are the people that receive the treatment. And I say that because sometimes it's difficult to actually look at an experiment and decide who is receiving the treatment. Okay, so that's what you're looking for. A response variable is basically what you're measuring. Okay, what are you looking for? What kind of a response are you getting? Now, Charles brought up a good point. In science class, what is this called? The what? The dependent variable. It's what you're measuring. It's the y, right? It's what you're trying to get a response out of. Okay. A factor is something that is controlled by the person that is running the experiment. We'll look at some examples of plants today, where we can control possibly the amount of light that a plant gets, or we can control the amount of food that a plant gets, that kind of thing. But those would be considered factors of an experiment. Okay. Oftentimes, you'll find different combinations of several different factors, and we'll look at that again today, especially when we're growing plants. They need both food and light. We probably need to control both of those things. And then treatments are what actually is being imposed on the subjects to produce a response. Now, what actually makes an experiment is whether or not a treatment is involved. Okay? If there is a treatment involved, we classify it as an experiment, period. Now, we're going to talk today about a good experimental design and what are the necessary factors, and there are 3, sometimes 4 things that we need to happen in order for an experimental design to be considered good. Okay? But anytime there's a treatment involved, it's an experiment, period. Okay? And that's really, really important. I've seen that come up on the AP exam over and over and over again. Okay? So if it's an experiment, if there's a treatment, period. Okay? Now, what are the 3, sometimes 4 key parts to experimental design? These are things you absolutely must write down. Okay? You really need to know this. I tried to highlight the 3 things. I'll highlight the 3 essentials here: randomization, control, and replication. Okay? So write those 3 terms down, and let's talk about what they mean. And we'll look at this other 4th one kind of differently, because it can't always be used. But if you're looking at something as an experiment that is a well-designed experiment, as we know, randomization has kind of been key all along for us, hasn't it? It was important in our survey design. It was important in our simulations. And it will be important throughout the rest of the course. You can pretty much always assume that you must randomize. As we learned before, what does randomization do? It tries to eliminate as much bias as possible. It prevents bias, right? And that's really when we talk about surveys. But experiments can also be biased in some way, the way that you collect your data. But how we we aren't going to, so think about, let's think about an experiment, let's create a hypothetical one. Let's say that Mrs. Macker wants to conduct an experiment to see whether sleep has an impact on grades on a test, okay? And so I have two groups of people, two groups of students, one who got 8 full hours of sleep, and one that, how many hours do y'all want to get? Like 4 or 5?
5 hours.
Are you okay?
Yeah.
Cramp?
No.
Okay. Okay, move on. All right, so 4 or 5, how many, I don't know. It's terrible, right? Really, how many little city bell people get, but two.
I got like 5 hours.
All right, let's say 5 and 8, okay?
5 and 9.
5 or less, and 8 or more. Let's do it that way. All right, so I have two different groups, okay? And I have a treatment. What is the treatment in that case? Sleep. That is the treatment that is being imposed on my subjects. Who are the experimental units? The students, okay? How could I randomize this case? Am I going to take volunteers? Am I going to randomly select people to be a part of my experiment? No. Oftentimes, people that are involved, or subjects that are involved in experiments, are not randomized. You ever see those commercials on TV? It's like, if you have ADD and want to be a part of this experiment, please call blah, 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 blah. You ever see those commercials on TV?
No.
They're trying to find people that are involved, that have their particular ailment, and they want to be a part of this future study. Okay? So randomization does not happen with the people volunteering. Volunteers are almost always used. How we randomize is what treatment group you get put in. So let's say I take this class, okay, and you guys are going to be my experimental unit. Okay? You're my subjects. And I'm going to say, if your last name begins with A through F, you're going to sleep for 8 hours or more. I'm going to call your parents. I'm going to make sure you're going to go to bed on time. Yada, yada, yada. Okay? And then if you have, let's say, the rest of the alphabet, you can stay up all night. I don't really care. Okay? Play Xbox. Go for it. Woo! I don't care. Do your homework. Do whatever you gotta do. No sleep for more than. So I would randomize my own way. Okay, I'm not sure that's the best method of randomization. I might say, okay, pick a number 1, 2 as you come in the door. And if you're 1, you're in this group, and 2, and you're in this group. We have to find a way to randomize which treatment group you go in. Okay, that's the randomization. A control is the second key element to experimental design. And control is somebody or a group of people that do not receive a treatment. Okay? So there's no treatment in a control group. So there's no real treatment. Sometimes we call it a placebo. Have you heard of that before? A sugar pill. Okay? And that is often used when you're looking at a scientific study with medical. Okay? A lot of times they give you a placebo because they want you to think that you're getting a treatment. And sometimes, you'll actually read about this, sometimes placebos or sugar pills, if you're in a medical study, have shown to actually, sometimes that happens. They call that the placebo effect. Okay? And all that means is that if the placebo has a better effect than the actual treatment that you're trying to measure, then that just kind of disqualifies your treatment altogether, doesn't it? Okay? So what the control group or a placebo is really meant for is to compare your treatment groups to. Sometimes you're comparing them to people who have no treatment. Sometimes you call it a before and after design, where we say, okay, the first night you're going to sleep for your normal 6 hours. And then I'm going to figure out what grade you got. And then the next time I'm going to have you sleep for a full 8 hours or more, and we're going to look at your test score. And we'll compare them. We have a before and we have an after. Sometimes you can act as your own control group. That happens too. Replicated. Okay? Replication is something that means, well, there's two kinds of replication. The two kinds of replication, or you must have more than one in each treatment group. Why do you think that would be important? Why do you think that if I only had one person who slept for 6 hours and one person that slept for 8 or more hours, why is that not enough? They could be outliers. They could be unusual people. You might have. I have a sister-in-law that literally doesn't need any more than 3 hours of sleep a night. She's like an anomaly. I've never met anyone with so much energy. I mean, it's bizarre to me. Okay, I need. If I don't get 8 hours of sleep, I'm evil. I've probably been in a bad mood in this class once or twice before because I didn't get enough sleep. Okay, so I'm as my daughter who's next door, she's probably sitting there going, you know, we'll go get her in a little bit. We'll meet her, but I need my sleep. Okay, but Aunt Julie doesn't need enough sleep. She's all right. So it's important that you have several people. Now, how do I know what's enough? I don't know. You know, that's kind of a tricky thing. But you just need to show that you have more than one person in each treatment group. Okay? Now, we'll talk about blinding. I think that's what that's supposed to say. Not binding. But blinding. Okay? Blinding. Okay, we have what's called single blind and double blind.
That's like poker.
Is it poker? No. Lots of vocabulary. So, with Mrs. Mackard's experiment with the sleep thing, blinding can't really come into play. Because blinding is when the people that are receiving the treatment don't know what treatment they're receiving. I have a feeling that if I told you to sleep for 6 hours, you would know how much sleep you got, right? It wouldn't be like that. I couldn't blind that. It'd be like a mystery. You only have 4 hours. Surprise! How would you know? So, how would you not know? I guess. Right? So blinding comes into play kind of like when we talk about treatments in a medical situation where there's an actual sugar pill or placebo. You don't know whether the treatment you're taking is actually going to help your foot or not, or your hurt knee, like Sam has a hurt knee, right? So you don't know if what you're taking is the real treatment or if it's a sugar pill. And that's called a single blind. The person that's taking or receiving the treatment doesn't know which treatment they're receiving. Okay? So single blind is when the subject is unknown. Subject does not know the treatment. Or does not know which treatment, I should say that. Now, is blinding essential to good experimental design? No. It's really not. Because not everyone can have blinding, right? Like my sleep study could not be blinded. Okay? It's good to use if you can use it. So you want to look for the availability. But randomization, control, and replication are the 3 essential key pieces. And anytime I ask you to design an experiment, you must address all 3 of those. Okay? What do you think double blinding would be? Charles?
If both the person who's receiving it and the person who is administering the treatment.
Can you think of a situation where that could occur? Or why it needs to occur? Let's say, anyone want to try before I jump in?
I'm thinking somewhere.
So, I maybe have a suggestion for you.
So often that's just like scientists do that enough doctors to give to people.
Exactly right. And the doctors aren't. So like that's an example. So like there's a green pill and there's a blue pill. And we're randomizing who gets the green pill and who gets the blue pill. And the person who's giving you the nurse is like, oh, you're in the green category, here you go. You're in the blue category, here you go. Okay, you're in the green, here you go, etc. But you don't know which one's the treatment and which one's not. You just know one's green, one's blue. That would be a double blind. The person receiving it doesn't know, the person giving it doesn't know. Now someone has to know, right? I mean, obviously someone out there in medicine land would have to know that the green is the treatment, the blue is not, right? But a double blind would be in that situation. kind of harder to do that. Doesn't happen as often. But double blind is both the subject and the person administering doesn't know which treatment.
Oh.
And again, it doesn't always happen. Why might it be necessary though? Amanda, which one?
Because like if you don't know whether or not the treatment you can't have false expectations or false hopes.
Okay, so the person receiving it, oh, I'm getting the treatment, it's gonna work finally. If you know you're getting the treatment, then you might have a different expectation of the outcome. Why might a double blind be important though? Why might it be a good idea for the person administering it not to know?
That person can't show bias towards someone else. Like say person may find a green pill, but it's kind of like this kid is kind of like a jerk to them. But there's like this sweet old lady that and if they know like the green pill is the one that is their medicine,
Right.
they're gonna want to give it to like the old lady.
Their friends,
yeah.
whoever they like. I really love Judith. And I really want to see her have some good results. Yeah, exactly. You don't want that to be the case. So it's good to have blinding on both cases if necessary. Yes.
When I was in university studios, like these like just random guys, like they pulled over my sister and I for doing a survey too. And what they did was like they wouldn't tell us like what we get. We get like 2 different types of teeth, that's all we get. And we was like walk in the room, answer all the questions, like have a cup of water and have a saltine cracker. So like we get rid of anything that we get. And then like they put a blindfold on us and like taste it. And we don't know if we got like the vegetables that we get or like some chicken thingy that
Right.
we didn't know, so we just like tell them like that. And they didn't know either because they brought it in like little
right. So they don't want to be biased either. They want to try. You're really trying to eliminate as much contamination, if you want to think about it that way, as possible. Good. All right. So let's go back up to the sometimes for. Okay. So I'm going to put a 4 here next to blocking because sometimes blocking is important. Now, what is blocking? Well, blocking might be, I'm really interested in this sleep study, okay? I really think that sleep has a major effect on test scores. But I also think that age might play a factor, okay? I think that the younger you are, the more sleep you need. So I think freshmen really need 10 hours of sleep. I really think that, maybe sophomores only need 8. But maybe as you get older and older, you need less and less. If you're my age, you need 0. It probably comes back around. They don't need as much because their bodily functions, they're not growing and things like that. My brain is actually supposedly on the reverse. My brain is dying at this point. It's kind of sad.
They're also shrinking.
But blocking is when you take your subjects and you break them up into like groups. Kind of like stratification with surveys, right? It's a little bit like that. But what you're doing with blocking is you're trying to reduce lurking variables. So if I think that age might play a factor, I'm going to put all people of like ages together so that I can look within each of those blocks and decide whether or not the treatment had a bigger effect or not. Okay? So blocking is often used, and sometimes you have to use it. Because if you have 2 totally different types of things receiving a treatment, you have to block by that type. I'm going to say that again because that's going to be important on your investigative task that you're going to get on Thursday. We'll say it one more time. If you have in your subjects that are receiving a treatment, and there are 2 or 3 totally different types of people, groups, things that are in my subject group, you must block by their specific types because you want to make sure that their type is not, or their whatever, if you have plant and an animal, you want to make sure you block by that to make sure that you're looking at how plants receive the treatment, how animals receive the treatment. Okay? So you really need to make sure you're looking at your subjects And if there are multiple types of things in your subject groups, you need to block by that. Okay? Good. How do you feel about all this vocabulary? You can handle it? This unit does not feel like a math unit to me at all. We will get back to math very quickly, I promise. Okay? All right. So, let's go ahead and look at an example of an experimental situation. Okay? Here's an example of a one-factor experiment. Okay? And I'm looking at, I'm a gardener. I actually like gardening, believe it or not. I know I don't look like I do, but I do. I like to grow all kinds of things. So let's say that I want to figure out the amount of water needed so that my flowers are going to look the best. Because I have learned over time that too much water is a bad thing, not enough water is a bad thing. So I've got to think about something inside. So the amount of water that is given to each group of flowers is going to be the treatment, because that's what I'm imposing on the flowers. I'm giving them water. Water is the treatment. Is it an experiment because of that? Because every time that you are administering a treatment, you have an experiment, no matter what, right? So I have a treatment. What are the key elements to experimental design? So in this case, what do I need to address? How do I address randomization? I have decided to do these 5 treatment groups. No water, light water, medium water, heavy water, and very heavy water. So I've got 5 treatment groups. Good enough. How do I randomize? So I get some flowers. What has to be true about those flowers? They have to be the same kind of flowers. I'm going to pick a variety. Let's pick the, I don't know, some kind of rose, or I don't care, whatever. Marigolds, whatever you want to pick. But one kind of flower, okay, unless I'm going to block by multiple flower types, but I'm just going to stick with one flower for now. And I'm going to randomize which treatment group they go. So I'm going to go to the garden center. I'm going to get a flat of marigolds. I'm going to say, okay, I'm going to go through and start. The first one's going to go in group 1, second one group 2, group 3, group 4. We'll just divide them up into 5 groups. So address randomization. Second thing. What is the second key element? Control. What's my control group? The no water is going to be my control group. It happens to be one of the treatment groups, correct? Okay. Unfortunately, no water is probably going to kill the thing, but makes me sad. But at least there's something there to compare it to, correct? Okay. And then we have randomization control, and so what do I have to ensure? That I buy how many marigolds? More than 5. At least 10. So I have 2 in each treatment group. 15 might be best, or even more than that. Okay? Good. Sometimes you have something called multi-factor experiments. Okay? So let's suppose that the amount of water is important, but the best time to water the flowers is important. I don't know if any of you guys have a sprinkler system in your yard, or you worry about watering the plants at all, but you should always water in the morning, never at night. Because if you water at night, then the water stays on the top of the leaves of the plant and it causes mildew. It can actually kill the plant. So you actually want to water in the daytime so the sun can warm them up. They have their water, they have the sun, chlorophyll happens, and they get to make their own food. Anywho, so that's way too much information that you need to know. But let's say that I have 2 factors now. I have my 5 treatment groups of the water, and I'm also going to break it up into how I water in the morning and water in the evening. How many factors do I have? I have 2 factors. What are the 2 factors? Louder? Water amount. And how many different, and time. How many different water amounts do I have? 5. How many different times do I have? 2. How many total treatment groups do I have? How did I get that if I didn't look at the chart? I multiply the 2 numbers. You what? You can do that? See, it's math. I just showed you. Math. 5 times 2. That's math hands to get right now. Okay? But that's what you're going to do. And in your homework that you're going to have, you're going to be looking at the different factors. And we call these, there's 2 factors. There are 5 levels to the first factor. There are 2 levels, the second factor. You multiply the levels to get the total treatments. How many factors were there? Just 2. Right? There's just 2 factors here. But one of those factors happen to have 5 levels to it. Fair enough? Okay. So, back a while ago, my oldest son used to play golf. So I ruined his problem a long time ago. He's since left golf and now does football, but whatever. Don't care about concussions. Anyway, all right. Last game today, by the way. All right. So a study is to be conducted comparing the driving distance of the different brands of golf balls. And I got 40 golfers. I want us to design an experiment. So Sandy said, design, that's nothing. Let me show you what's involved and what is entailed and what that would be. Okay? Who are the experimental units? Careful.
No, the brand of golf. It's driving. It's a golfer.
Y'all don't know.
Golfer.
So let's talk through it. Okay? So I want us, these by the way, these move. Okay? So you're gonna match them up. Right? We're gonna match who goes with what. Move this around. Here we go. All right. So, is there something that I know I can put up there that I know the right answer to, Mr. Alford?
The tracking distance to the response.
Good. What I'm looking for and what I'm actually measuring is how far the ball goes, right? So the response variable is going to be the distance of the golf ball. I agree with that. Good job. Okay? So let's keep going. Okay, what else do we have? Is there anything else I know for sure?
What do you know?
Erica, put your phone away. What you're manipulating, what you're changing, the treatments are going to be the different brands of the golf balls. Okay? And there are 4, well, hang on, which one is it? The brand or the 4 brands?
The brand.
Okay. Would you agree that these right here are the factors? Would you agree with that?
Yeah.
Okay. So, well, these 2 are what we're looking at. Would you agree? Okay. So the level of the treatment and what I'm manipulating. So how many factors are there? There's 1. There's 1 factor. It has 4 levels. Okay? But the 1 factor is simply just the ball. Okay? So the brand of the golf ball, there we go, is the factor. The treatments in and of themselves, we have 1 factor with 4 levels. What's 1 times 4? Here's the math. 4. So the 4 is the number of treatment groups I have. Are we good so far? Okay. And then the people that are receiving the treatment, people that are receiving the golf balls to hit down the fairway are going to be the golfers. Yay. Yes.
I have a question on why the golfers would be, I guess, prepared for this. They're not being ready for the golf ball.
The treatment is the golf ball, right? That's what the treatment. That's what's being given to the person, and that is what's being manipulated for the response to happen. Okay? Yes.
Vary a lot depending.
Louder. Say back there.
Flames of the golf vary a lot because of the 40 different golfers.
Yeah, and that's a key. Absolutely that's a problem, and I agree with you. So this is not the best well-designed experiment. I think maybe rather than the golfer, you would probably, here's those golfing machines that swing them, and I mean, to be consistent and all of that, I agree.
You would control golf ball and like see what they would have got from a regular golf ball.
Yeah, before and after design might have been better too. I agree with you. It's not the best example. But I'm not done. Okay? I want to design it. When I design an experiment, let's make sure when I design it, I need a picture. Okay? So you need to put all of this information into a picture. And let me tell you what the important piece is. So we we call this a diagram. How many different treatment groups are there? 4 treatment groups because there are 4 brands of golf balls. Would you agree? So I'm going to take my 40 golfers, which I have here, and I'm going to divide them into the 4 different treatment groups. But what should I be careful about? Because those are 4 treatment groups, and you always told me randomization is key. So what's going to be really important is that you randomly assign which golfer gets what ball. Okay? Can you give me an example of how we could do that? Sam. Who just kind of walks in the room? Okay. Possibly that's a way to do it. Could we take all 40 all 40 golfers and number them 1 to 40? And then I could say, could I randomly start the, I don't know, let's say, I could pick numbers of a hat. I could randomize the starting point on my list and then do a systematic sample from that point, right? And every 4th person gets, that kind of thing. Yes.
Give each of the 40 golfers a bucket full of 40 balls, 10 of each, and have them.
Well, that's a totally different design. Okay? So be very careful. And I want you to really listen to what he just said. He said give them a bucket of balls with 40 balls, and there's 10 of each in there. The problem with that is what? Well, the treatment is still the balls. How would I know which ball is what? I could color them. But the way that I have designed it here, okay, is that I have randomly picked a golfer for each ball. Okay, I'm not saying it's the best design, but that's what I've done here. And that's what this picture is saying. Your picture will be totally different. Okay? Yes?
What if you have like a sampling screen of your experimental
Yeah, that's kind of what we were just saying. You can randomly pick which one goes into each one. The sampling frame being the 4 different balls, correct? All right, so once we have our randomization, and we're going to explain how to do that, we'll probably write a little sentence down here that says how we randomize. How many people go into each treatment group, or how many golfers go into each treatment group? 10. So we need to say that. We need to tell how many subjects go into each treatment group. Okay? And so that's what I've done here. 10 in each. So what's been important so far? I've addressed randomization. I've addressed replication. What else do I need to address? Control. So a control is something that is not addressed here. So it's not the best design. What Sammy was saying earlier is a better design may be to compare what I hit with the new ball compared to what I used to hit before. Every golfer knows what their driving distance is on average, okay? Let's say it's 318 yards. No, it's not. But whatever yours happens to be, you can compare it to your average. Your average would be the control, okay? Now, at the end, in your picture, in your diagram, you always want to compare the driving distances or compare the treatment groups. In this case, it would be the driving distances and the balls. So that is something you always want to do at the end. Okay? Now, it does say replicate the entire experiment if possible. We've already addressed one form of replication because we have 10 people in each treatment group. The other form of replication is just to repeat the whole experiment. What might be some issues with that? Okay, the golfers might be tired. Think about outside of this particular experiment. In any experiment, what might be the issue with having to repeat it all again? You might, the soreness, the people might get tired, you might have to have different people. Okay? To conduct a real experiment costs money. And to repeat an entire experiment again is money and time. Often which we don't have one or the other. Most often we don't have both, right? So you want to make sure that whatever experiment you do it the best you can at the time. Okay, you address all the elements at one time as best you can. Okay? All right. Here's another kind of experimental design. It is called randomized block design. Okay, there are names of different types of experiments. This is a popular one. So I'm going to leave this, and this will be the last thing we talk about. Lots of vocab today. This whole unit is like vocabulary. It's very, very intensive. So, anyone who's ever played golf knows that there's women's tees, and then there's regular tees, and then there's pro tees. Okay? And sometimes there's junior level too. Juniors are in front of the women. Depends on what kind of level of golf course that you're at. But you have it goes juniors, women. I think it goes juniors. Hopefully it's not juniors. I think it's juniors, women, regular, 4-year-old men, I guess, and then pro. Okay. So blocking by golfer type might be important. Would you agree? Because people that are pros probably drive longer or farther than people that are women or juniors. Juniors being, I forget what the age is, I think it's 16 and younger. Anyway, so men and women is the one I pointed out here. So blocking by gender in this case would be appropriate. You could also block by juniors and pros as well. So you might want to consider those if they happen to be in your subjects. Do you think you're going to have a bunch of pro golfers volunteer for your experiment? You may, if you're like, if you work for Titleist and you work for a major golf company, then pros might want to try out to do bowling. You never know. So you really just want to look at who's in your subject area. Okay? So how would the picture look if we're just going to worry about gender? Let's say I don't have any pros, I don't have any juniors, I only have men and women. Here's how my experiment looked before. How does the picture change when now I've introduced women and men? I have 40 golfers. I need to have 20 females. And I need to have 20 males. Would you agree with that? Okay? At this point, I need to divide each of these blocks into 1, 2, 3, and 4. I don't know what their names are. I can't think of different golf ball types right now. How many go in each of those treatments? Oh, by the way, we don't randomize whether they're male or female. What do we randomize?
Which group they go in.
So we're going to randomize here. Would you agree? And we're going to randomize here. Where you randomize is important. And then how many, if we have 20 divided by 4, 5, right? So we're going to have 5. So have we addressed replication? So we've addressed all of it at this point. Control is a little weak. I agree with Mr. Bonani. I think that control, we have to make sure we say, compare the driving distance with the new ball to your, whatever your particular driving distance normally is. Now, I'm still not done with my picture. What do I need to do? What did I tell you to do before? Coming together. How do I say about that? I'm going to compare some things. What am I going to compare? Within each block or to each block? Probably both, but definitely within each block. So we need to compare here. We need to compare here. Now, those are going to be the most important comparisons because we've really blocked by gender, knowing that women and men have different driving distances. So those are the most important comparisons. You might also want to compare here as well because maybe, women had a much better significant change with a certain one versus another. Women responded to ball number 3. I don't know. I can't think of golf brands right now, but all I think is Titleist. I know that's more than that. Anyone? Huh?
Blue, Prater, Fizz.
Oh, I'm thinking the names of golf balls.
I'm thinking Fight.
Callaway, thank you. Thinking of a brand. Anyway. All right. The picture looks a little bit different. Okay? How do you feel? Vocabulary. A, anytime you are asked to design an experiment, you must address 3, sometimes 4. The 4 would be a block, and this is a randomized block design. You randomize within each block which treatment group they go in. Okay? How many treatment groups are there here? There's 8. Okay, there's 4 for women, there's 4 for men. A total of 8. All right. So let me go ahead and give you your homework, and it's going to be on chapter 13 now. And this is the last chapter before we take our test in this unit. Okay? So we are going to have a test on all of data collection at the beginning of next week. So I do want you to read chapter 13, where it talks more about the different vocabulary. So that's the first thing. Read chapter 13. Lots of vocabulary. And then I do want you to do 2 through 20 even, where it talks about, guys, please listen. 2 through 20 even is all I'm going to have you do right now. Okay? Actually, I'm going to give you 1 through 20 all. You know why? Because you have to really make sure you understand the difference between an observational study and an experiment. All right, so let's listen. What you need to do, and it tells you the directions at the beginning. All 20 of these are just scenarios. Okay? So I'll read the first one. And what you have to decide is first if it's an observational study or is it an actual experiment. What am I looking for to make that decision? Treatment. Is there a treatment? If it is, it's in the experiment design in the category already, right? So here's the first one. We'll just talk about it together. It says over a 4-month period, among 30 people with bipolar disorder, patients who were given a high dose of omega-3 fats from fish oil improved more than those given a placebo. Is it an observational study or an experiment? So we know with number 1, it's an experiment. You're asked a couple more things. If it's an experiment, you have like 7 things to identify. If it's an observational study, you have like 4 things to identify. But they're listed here at the beginning. So for example, who are the subjects in this? The people that are receiving the treatment. So they would be the patients. Would you agree? So the patients are the subjects of the study. The next thing it asks you are the factors in the experiment and the levels of each. In this, the factor was the omega-3 fats. Do you agree? Then you have to figure out the levels. We'll just high dose versus non-high dose, I guess. I'm sorry, what, Steve? The placebo does not count as a factor. It counts as a level of treatment. Okay? High and none, high and low, whatever they happen to give you. Okay? All right, so are there any questions as to what I'm asking you to do? All right, that's it.